Welcome back, Pre-Algebra. We're in Lesson 2. We're going to talk a little bit about the number line and ordering numbers. So the number line is a line, obviously, and it has numbers on it. So it's pretty self-explanatory. You have a number or a line with numbers on it. And that number line is always centered on the number 0. That is our origin. That is what the number 0 is. It's the very center of our number line. And then from there we have numbers to the right of the 0 or the origin, and we have numbers to the left. And it's important to realize that these are whole numbers. Now, in the real number system, we have a few different sets. And the first set of numbers that we talked about in our previous lesson was or actually there were two sets. We talked about the digits 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, right? So those are our numerals that represent the ideas that we have for quantities of numbers or quantities of things. And we naturally begin counting numbers with 1. Like if I had a series of dots here, I wouldn't start counting with 0. I would start counting with 1 and say 1, 2, 3, 4, 5. We have 5 things. So in mathematics, we have a set of numbers called the natural numbers. And natural numbers are the set 1, 2, 3, 4, and so on into infinity. And then we have a set called whole numbers. Whole numbers recognizes that you can have nothing. That it includes the concept of 0. So it begins with the number 0 and moves on into 1, 2, 3, 4, 5 and on into infinity, because you can always add one more. You can always have more numbers, right? Well, with the number line, we identify a third set of numbers, and that third set of numbers includes negative numbers. So we've been exploring positive numbers so far, and positive numbers are on the right side of the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. You keep going. It goes on and on into infinity, just like our natural and whole number sets do. But on the other side, to the left of the 0, we have the opposite of these numbers. All of these numbers have an opposite. These are positive numbers, and these are what we call negative numbers. So the opposite of positive 1 is negative 1. The opposite of positive 2 is negative 2, and then we have negative 3, negative 4, negative 5, and so forth and so on. For every positive number that we have its opposite or its negative. All right. So I'm illustrating that for you here. So you can see how that kind of works. It's almost like a mirror. Like this is a mirror to this side. And whatever you see on this side, the opposite is over here. Whatever you see on this side, the opposite is over here. So the opposite of any number, you just change the sign. So the opposite of negative 6 would be positive 6. And the opposite of positive 8 would be negative 8. And the reason we call it opposite is because you move that number of spaces in the opposite direction from the origin. So if I wanted, let's say 1, 2, 3, 4, 5, I wanted the opposite of 5, I would go the other way. 1, 2, 3, 4, 5. The opposite direction would give me negative 5. Same number of spaces, both ways. So that's why we call it the opposite, because you're just moving in the opposite direction from the origin to find that number, but it's the same number of spaces, or what we say is the same distance from 0. Right? So these are theoretically supposed to be the same distance apart, but Miss Tracy's not that good of an artist just yet. So we just assume that they're the same distance. It's the same number of spaces. We call that set where we include all of the positive numbers, 0, and then all of the negative numbers, we call those integers. And those are still just whole numbers. We're not into fractions or decimals just yet. So natural numbers are, we would write sets like this with these little cute curly brackets. We would start at 1, 1, 2, 3, and then this is an ellipse, and it indicates going on into infinity. You can never find the end, right? Whole numbers would be natural numbers plus 0, and then on into infinity. And then our integers would be, if I can spell it correctly, integers. We would have a curly bracket here. We have to indicate that the numbers go into infinity on both sides. So let's say -3 here, -2, -1, 0, our origin. You always have to include the origin. And then you go, usually whatever you start with is what you finish with on the opposite side. So 1, 2, 3, and then an ellipse to indicate that it also goes off forever. So on a number line, when we draw one, we include arrows on each end that indicates for us this ellipse, that it goes on and on forever in each direction. So this is the illustration. The number line is the illustration of the set of integers. So you can think of it like that. We illustrate the origin, and then some numbers on the left and then some numbers on the right that are about the same, usually the same numbers, and then an ellipse on either side of that to show the arrows of the numbers going on and on forever in both directions. So those are the three sets we have talked about within our number system so far. You're going to want to know those because it's going to come up on a test. Put that in your notebook. All right. So what does this mean? How does this affect place value and the value of number? Well, whenever you have a number that is to the left, the further to the left or the further away from 0 it gets, the less it is worth. It's like digging a hole, right? The more you dig the hole, the less dirt you have. Whereas the more you pile dirt on top, the more dirt you have, right? So here we're subtracting, and here we're adding. And that's why we use the minus sign for the negative sign, because we're subtracting. And we use the, on the positive side, we use the plus symbol when we want to combine numbers because we're adding, right? And we use the positive, the plus sign, as the positive sign. So subtraction and addition, these are negative. So the bigger the negative number, the less it is worth. The bigger the hole you're digging, right? And this is the bigger, it's kind of like this. If I give you this illustration, you add a pile of dirt on top, you add another pile of dirt on top, you have more shovel. If each one is a shovelful, you're going to have a bigger and bigger pile of dirt. Whereas over here, let me get a little thing here. For every shovelful you take away, you have less dirt, right? So this is the level of the land. These are piles, which is the positive side. And this is the shovelfuls that you dig out, which would be the negative side, right? So the bigger or the more shovelfuls of dirt you take away, the less dirt you have. The more shovelfuls of dirt you add, the more you have. So that's how it's kind of, I think of it, and it kind of illustrates it to me as, you know, a big hole versus a big mound, right? You add or you subtract. And that's what the number line illustrates for us. So if I have a -4, and let me erase this right here for us so it's not in the way. If I have a -4 and I have a +2, which one is worth more? The -4 or the +2? Well, the positive 2 is worth more because I've added a couple of shovelfuls of dirt. I don't I'm not going in the hole, so to speak, right? Pun intended there. And the one that would be worth less would be the -4, because we have gotten rid of some of our dirt. We've removed something to get to the -4 from the origin. So what about if I had two of the same number? Let's say I have a 7 and I have a 12. Which one is worth more? Well, the 12, because I have 7 ones and one set of 10 and 2 ones. So this is more for sure. What about if I have a -7 and a -3? Which one is worth more? Oh, they're both negative. How do I know? Look at the number line. The further to the left, the deeper the hole, the less you have. So -7 is further left than 3, the -3. So -3 is worth more than -7, right? What about if I have a -5 and a -12? Which one is the greater value? Which one has more value? The -5. Why? Because the -5 is closer to the 0 than the -12. The -12 is further away from 0, and therefore the further to the left you get, the less it is worth, right? The deeper the hole, the less dirt you have. So -5 would be worth more. So what if I had a group of numbers here and I wanted to put them in numeric order? Let's say I have -11, +12, -2, 0, and 4. What order would I put them in so that they are in the proper numeric order? Well, all you have to do is think about your number line and put them in the order from least to greatest based on their position in the number line. So least to greatest, we're going to order these numbers. So let's look and see what the biggest negative number is. Well, the biggest negative number is -11, so that would go first. What's the next biggest negative number? -2, so that would go next. Well, then all I have left is 0 and some positive numbers. And 0, let me add, is neither positive nor negative. It is neutral. So that's why it's called the origin, because it's not positive or negative. So it would go next because it's not positive or negative. It's right in the middle of all those numbers. Then what is the next biggest number? That would be 4. And then 12 would be the last number, because 12 is further to the right than 4. So we know as numbers go to the right, they get bigger and bigger and bigger. And that is a logical progression, because we have -11, then we move to the right to -2, 0, 4, and then 12. So these numbers are in numeric order from least to greatest based on their place on the number line. And that's how we would do that in our practice problems as well. All right, so now we know everything we need to know about the integers on the number line and the positives and the negatives and how they relate to one another. So let's talk about how do we round partial numbers to get to the integers. Like if I have part of a number and I want to say it's close to a number, it's about this much, how would I do that? So I'm going to clear the page and we're going to talk about that. So let me give you an illustration of a number line. And I need my pen. I'm not going to write all of the integers. I'm just going to write a few of them. So I'm going to start here. Here's my 0. I know it's not in the middle. I don't need the negative side, so I'm not going to draw that. I'm going to skip some numbers and I'm going to do 100. I'm going to skip some more numbers and I'm going to write 200. And then, let me see, I think I'm going to skip some more numbers. Let me stretch this line out just a little bit more. And I'm going to write 300 here. and then I'm going to put my arrows to show that this goes on and on in both directions. When you draw your number line, you need to put the arrows to remind you of what it is. As we get into a little bit of geometry and we start doing line segments, it can be confusing if we don't include the arrows to show the difference between a line and a line segment, and you'll see what I mean when we get there. But for now, just remember to put your arrows on each end of a number line. So let's say I have a number 209, right? And let's say that I want to tell somebody in a very general way about how many bags of flour I have, right? And I'm not trying to brag or anything, but they just want to know about how much space they need to give me to account for that much. Like, let's say I'm renting some space from a storage unit and I want to put my bags of flour in a storage unit, and they want to know, okay, well, how much space do you think you're going to need, right? So I need to tell them a quantity, but I don't have my inventory in front of me, so I want to kind of round that number. I want to say a number that I think is pretty close, but I don't want to pay for more space than I need. And their units, come in these sizes that they have. So I want to get the biggest space. I want to get the space that most likely is going to accommodate what I need. So I need to tell them about how many bags of flour I have so that I can get the right space. So I need to round this number down so I can approximate that to the best size. So what I'm going to do is I am going to look at the place value for what I need. And what I need is to tell them about how many 100 bags I have. So I'm going to look at the place of, or the digit that is in the place value I'm rounding to. In that case, I want to round to the hundreds place. That would be this place right here. Right? So I look at this digit here. How do I know what I need to tell them? Do I need to go up? Do I need to go down? Well, the way we do that is to look at the digit right next to it, which is a 0 here. And what we want to do is say, okay, in order to round, here's the 200, here's the 300. If it is halfway, right here, or more, then I'm going to go ahead and get the 300. If it is halfway, or if it's less than halfway, I'm going to get the 200. So halfway, half of 100 is 50. So 250 would be my halfway point between 200 and 300, right? So if it is more, it's halfway or more, I'll get 300. If it's less than halfway, I'll get the 200. So we look at this digit and we say to ourselves, that's 209. That's in the 200s still. That would be about right here. So that's less than halfway, right? So less than halfway is going to be 200. So I would tell them I have about 200 bags. And that's how we do that. We look at the digit here and we ask ourselves, is this 5 or more? Because 5 is going to be the number on our base 10 system that is in the middle. That's the halfway point. If you look right here, that next digit was a 5, 2, 5. If it is a 5 or more, we round up. So 5 or more, we round up. If it is 4 or less, we round down. So I had a 0. A 0 is less than 5, right? It's 4 or less. So we went down. It was closer to the 200 mark. So we did that type of a rounding here. Let's do another example. Remember, if it is 5 or more, we round up. If it is 4 or less, we round down. So let's say I have 193 pennies, and I need a jar that's going to hold them. Okay. And jars come in the 100 penny size, the 200 penny size, and the 300 penny size. I need to know which size jar will work for me. So approximately, how much is this? What size jar will I need? Well, instinctively, we probably know I need the 200 size because that's pretty close to 200. That's what you're doing. You're saying to yourself, it's closer to this number. But mathematically, we can look at, this is the hundreds place, this is the number next to it, it is greater than 5, so I'm going to round up. That's the mathematical process that you're doing when you say to yourself, it's closer to 200. That's all we're doing. And the line that we use is the halfway point. So the halfway point in this illustration would be right here. It would be at 150. That is the halfway point. 193 is probably right in here somewhere. So it's closer to 200. It is over that halfway mark of 5 plus. So we round it to 200. All right, let's look at another number. Let me look at something a little bit more complicated. So here is example 2.3. And we are going to take this number and I need to round this number for whatever reason to the nearest 10,000. So that is what I'm rounding to. I'm rounding to the nearest 10,000. So first of all, I have to identify what is 10,000. Where is the 10,000 place? Well, I know this is the ones grouping. The second one is the thousands grouping. So I have ones, tens, hundreds. So this is the one that I need to round. So I'm going to look at this next digit and I'm going to ask myself, is it 5 or more? Is it 5 or more? And if the answer is yes, then I'm going to round this up to the next number. And the answer is yes. It is. It is 6. 6 is greater than 5, right? It's 5 or more. So that means I'm going to bump this up to the next number and I'm going to round this number to 330,000. So 471,330,000 is the number that I'm rounding to. Notice when you have a bunch of zeros, you stop. You don't have to say anything else. So 471,330,000, that's your number. Let's try another one. Let me clear the page and we'll do example 2.4. So 2.4, let me give you the number. It's kind of a big number. It's 83 billion. Oh, wow, that is a big number. 752,914,625. And we are going to round this to a couple of different places. So first, we're going to round it to the nearest 10 million. Then we're going to round it to the nearest billion. And then we're going to round it to the nearest 100,000. Well, I should finish writing one word before I start the other, huh? And then we're going to round it to the nearest 100. All right, so let's start with 10 million. So first we have to identify the millions group. So ones, thousands, millions, all right? And within the millions group, we have ones, tens, hundreds. So right here, the 5 is our 10 million. So we look at the 5 and we look at the number next to it. And is this number 5 or more? Is it 5 or more? No, it's less. So we don't have to increase this number. We don't have to round it up. It stays right there. So the nearest 10 million would be 83,750,000,000, and that's it. It would stay here and everything else would be turned to zeros because we're rounding. We're just giving an approximation. We don't have to give all the little details when we round. So now we want to round it to the next billion, right? So let's find billions. So ones, thousands, millions, billions right here. So the billions place, we have ones and tens. So the ones is what we want. When there's nothing in front of billion, it's talking about the ones place. So that would be a 3. So what is the number behind the 3? It's a 7, right? Is this number 5 or more? It is. It's 7. So yes, we would round this number up. So we would round this number to the next number up, which would be 4. And then we put zeros in all the other places. So that'd be 84 billion when we round this number up to billions. So let's look at 100,000. So first let's find the thousands group. So ones, thousands. So within the thousands, we have ones, tens, hundreds. So that's 900,000. And the number next to it is 1. Is the number next to it 5 or more? No, it's not. So we would round down. So the 9 would remain the same and everything else would turn to a 0. So 83,752,900,000. That's how we would solve that. So now let's look at the last one. We want to round it to the nearest 100. So first we have to find the hundreds place. So here is our ones group. Ones, tens, hundreds. So that 100 is a 6. So we look at the 6, we look at the number next to it, which is a 2. Is that number 5 or more? No, it's not. So when we round to the nearest 100 here, we get 83,752,914,600. All right, so I hope that you're seeing the pattern of how to round these numbers. It is all about the number next to it. Is it 5 or more? And if it is 5 or more, then you round up. That means you increase the number you're rounding that you're looking at and turning everything else to zeros. If it is not 5 or more, then you just turn everything behind this number to zeros, right? Just like we did here. So if you have any questions of that about rounding, let me know and I can give you some resources on that. And that is all we have for lesson 2. I will see you in lesson 3.